errors when we see it is going to occur. So it is very difficult actually to make as a valid inference, and also appropriate prediction. Which one really is so important? You understand that statistical literature and prediction literature. Therefore, resolve multicollinearity problem actually is considered as a serious issue for the linear regression, say those actually they want to build their model. Even we have seen also like that problem of multicollinearity, say can be solved by various methods. Say there are some actually I'm going to mention. We may, when we see multicollinearity is going to exist, then one researchers actually what they do, they, if it is possible, say they may collect additional data if possible, say reselecting variables. Then we have a wonderful method, although my talk is not on that. That is principal component regression methods, reparameterizing the model. Meaning is that when we used a model, so we may, say, rebuild the parameter. There's also has a system. And the most important one, which one actually my topic today, that is actually ridge regression method. And also I think there are many other ways as. Okay. So in this talk actually, I want to talk about on this ridge regression method, where actually the problem which one actually occur when someone is going to build, say, a regression model based on their raw data. So uh, we can use ridge regression to avoid this problem. Okay, so now we should know actually this ridge regression concept, who actually first developed. So we have seen that the concept of ridge regression is first proposed by Horal and Kennard. It is actually very old story. It was 1970. He wrote a very wonderful paper. And those who are expert in this line, I hope they are familiar about him. To handle multicollinearity problem, he was the first person. He was guiding us, say how to overcome, say this situation by using another alternative method. Okay. So what actually they found? They found, say, I think, say, uh, actually I have no way to write. Okay, where is an I don't have the pad. So when we suppose if you have a model like this, y equal x beta plus e is an random error. So when we are going to estimate beta, I mean the model parameters, so yeah, the formula actually becomes x transpose x inverse x transpose y, something like this. This is the actually model parameter formula. So actually what this say researcher actually guided us. So with the Wallace estimator, he actually added a letter that's known as the K. That K actually is the ridge regression parameter. Later I will explain. So this is the reason, so it is written like this. So to avoid this problem with the OLS, actually we add one non-zero value of K, say, which means if you add this K, that means, empirical evidence we have seen, say, in that case, if you use K and if you do not use a K, so in that case, what we see the effect, the mean square error. When you are adding K, it becomes small. You understand that? Becomes small, meaning is that prediction will be, so better as compared to first one. Okay, so then when you calculate mean square error for each regression estimator, we have seen that it is a better estimate than the, say ordinary least square method. Okay. So now the question arises, because you understand that it is a 1970, so there are many research going on. Even we also did, some papers we have published. Okay, if you see the Google Scholar, you'll find hope so. Okay, so we have seen, say, many authors at different time, with their different, idea, they have proposed because they did simulation, they have a lot of evidence, and it is always available. It is available actually in our say rich regression say literature. So our work actually, what we have done here, even I'll talk, there are many actually rich regression estimators. Now first question now is arising, when one say let's say first user, when they are trying to use rich regression, when they have learned say by using the rich regression parameter, someone will be able to reduce the noise multicollinearity. That means one question they will face, meaning is that because there are many methods to find the value of k, so which method actually they will select? It is never possible for us to use 25, 30 estimators for a problem. So we are trying to say some words on it. That means we did simulation, we did real data application. By this way, we are trying to find a solution. Meaning is that I hope you are understanding our target to propose some good estimator of risk regression. Obviously, according to our simulation design and also which data set we have used. So actually our real work, I mean the core work, which one actually I'm going to talk on this, say how one researcher, can find the, first of all, when they will use which k value or maybe method they are going to use. For this reason, here I have mentioned, say actually it is not possible to mention, everybody's name. So most common actually I have listed here some. So if someone is interested, they may find. Even I'll talk also. My next section is I'll give you idea, say possible methods which are available in our say rich regression literature. Okay, so here's the author's name also, and I have added at my presentation at the end reference also. Okay, now the main objective of my talk, to do a comprehensive study on different rich regression estimators. So those are available according to our knowledge in literature. Still, we are actually working. So it is our one of prior work. So now also we are working, and many authors they suggested more estimators. Actually, sorry, I didn't include there. Actually, my target to say most common, and also say some of. Let's see actually what I'm going to talk. Okay, so here actually I'll try to give you idea what does it mean one rich regression estimator. Okay, let us consider one multiple linear regression model. I think it is well known, y equal x beta plus e. And I think we know that y is a dependent variable and x is independent variable, and beta is the set of parameters actually which is our target to estimate based on sample data, and e which one is a random noise, and due to sampling it happens. So I'm not going that story. One statistician actually they knows about what is random error, why it is happening, and how to minimize it. Our main target to minimize the value of e. And if you can minimize the value of e, you understand that then mean square error also will get less, and also our prediction which one actually will do, that will be at least we may say it will go close. Okay, so then I was trying to say what is the OLS estimator of beta. It is a well-known formula, that. So beta hat equal x transpose x minus inverse x transpose y. Okay, here the covariance matrix beta hat, which one actually denoted by co beta hat, that is actually I think sigma squared times x transpose x minus inverse. Okay, so then we have seen that say both beta hat and covariance of beta hat are heavily depend on characteristics of the matrix of x transpose x. So in that case, what is going to happen? Say we can see the standard error, say for that model actually become is a large value. Okay. Say then what we have seen, what we have done here, because I already talked. Say Horal and Kennard 1970, they are the first pioneer. They discuss, they say introduced us this concept of rich regression. And in that case, actually, what they have done, I said already, say, yes, I should say, when we see our matrix X transpose X, it's, becomes ill condition. What is the meaning of ill condition? Its meaning is that determinant X transpose X actually becomes zero. This is meaning actually ill condition. So in that case, what is going to happen? So beta hat actually becomes unstable. I told that before, and it is also true. I said in that case, so making a meaningful inference actually very difficult for one, applied researcher or practitioner or whatever you like to say. So to overcome this problem, say the author, we call it HK, he suggested a small positive number to be added to the diagonal, elements of X transpose X. We understand that X transpose X is a matrix. That means diagonal elements as there actually there should be a value k. The k has a formula a little later. That formula will be added, and as a result, rich regression estimators looks like is coming beta hat k X transpose X plus k IP inverse X transpose X. Its meaning is that what is actually IP? That is the identity matrix of order P, and others actually we understand that X is our explanatory variable and Y is our dependent variable. And I think so here, okay, I think say we understand the difference between OLS estimator and rich regression estimator. So again, I'm going to say this is actually beta hat k. Actually, that will be considered as a rich regression estimator. And OLS estimator actually familiar, say the different way, different times, different authors, according to their belief, according to their knowledge, they try to give us, say various estimators about k. So everything is available in literature. So if anyone is interested, they may see that. So here actually I will talk about as an abstract form. So let us see the first one, which are known as actually I told hk, and it is denoted actually by k hat hk. Let's see the formula what he suggested us. He said k hat alpha, hat square max. What is the meaning of that? Sigma square is the error variance of our model estimate of our model, considered model. And alpha actually, say that will be, if you have alpha, let's say there are three explanatory variables, you understand that they are actually, they have taken the maximum value. They have explained actually why they have done it. Okay, so our target for this talk, I'll make you familiar different estimators. Okay, so here, say Harrell and Kennard, they have showed in their paper, when they have added this value with the OLS estimator, they found better result as compared to the OLS estimator. That means he finally said it was minimizing multicollinearity problem by this way. And as a result, say when he gave application, we have seen that, say better prediction and other noises actually it was going to overcome. So here's the story of actually first author, which are known as the HK. And then, say different time, say there are several modification, there are several ways actually they are trying to, because this HK also suffers from many problems. Okay, so they found this kind of problem. Then let us see our next estimator. That estimator name is Horal, Kennard, and Baldwin, and it was actually suggested by 1975. So according to their paper, they have denoted this is k hat HKB. You understand that they use the initial. So we may see the formula for K hat HKB, and you may see what is this? It is P prime alpha hat. Okay, what is P here? P is the number of explanatory variables. If you compare with, say 3 and 4, we can see the difference. Actually, you are going to see the difference. It was alpha square mx maximum, and it is actually they have used alpha hat prime, and that why they have used that explanation has in their paper. Okay, so that means it is actually according to our paper, it is our second estimator. Let's go the third estimator, say Lawless and Wang, 1976. They actually did a modification of HKP because it also suffers problems, some problems, and they didn't find, that way as a MAC is less. For this reason, what they have done, they modified, so this formula in this way. So it is looks like is what okay, P sigma square hat dividing by the difference. We understand that they have added the explanatory variable as well. Okay, so they have showed the performance even we also did. Later I'll show you. So there are probably 28 estimators, and we'll find the best estimator, according to our simulation design. Okay, so we may see that, and I don't think I can explain all because I have other parts. So then say my co-author Kibia 2023, actually he modified and also suggested some say rich regression parameters, because it was his actually one of major work. And what he have done really, he used actually arithmetic mean, actually AM, which are known as AM, geometric mean HM, and median of, you can see that these estimator, what is that? Sigma square AM, and number 7, we see the same one. He actually calculated GM, geometric mean. You know what is the geometric mean? He used the geometric mean concept, and we find that there is other two estimators, which your name is KM and KGM. Okay. Then also what he have done, he used the second measure of average, which are known as 50th percentile, that, or second quartile, and also it is known as the most commonly median. So he used so that means he found the median of that, say expression. Okay, that means we may found our estimator 8. Actually, according to my presentation, I have given a name estimator 8. Then followed by, we have seen that Kalap and Shakur 2025, he suggested a value of K, which one is denoted by K hat Ks. You can see the formula here. So K hat Ks, actually it is just like this. Okay, so I think there'll be no noise. I'm talking from my office. And previously I had a class also. Okay, anyway, all right. So here there you can see this formula. You can see this formula. So here T max is the maximum eigenvalue of X transpose X. Okay, instead of explaining each of, I may show just, say as the 10th estimators, so it is suggested by Kibria and Kalap and Shakur 2025. Just scrolling now because I'll be out of time. Okay, so yeah, here is another estimator. So you may see that looks like this. Then we can see that I said you there are many actual research different time, different way. Okay, they are thinking, and everyone main target was can they find to an estimator where MSC mean square error can be less, and they can go for better prediction. This is actually always we want. For this reason, there are many estimators, many types, very old story. Okay, so you can see there's formula, all are modified formula. Okay, looks like that. Excuse me. And then You can see here has like this formula, so I don't think I can explain all. Okay, skipping those. And then the next author, say Shakur with his co-author 2028, he has given like this, modification. You can see that looks like geometry, but their expression is different. Okay, so if anyone interested, they may see, our this presentation or maybe our paper looks like that. Okay, scrolling again. There we see color 2024 proposed turn one estimator K, and you can see here is their form. Let me read this one. Okay, so K had GK is equal to K hat HK plus, it is 2 dividing by lambda mx plus lambda mn. So you understand that lambda max and lambda mean, these are largest and smallest eigenvalues of the matrix, X transpose X. So it is one estimator. So let's calling then. Okay. Then we can see the another estimator, which one is proposed by 1998, 1988, Nomura, and this looks like very critical, looks like, but she also has explained why her estimator, why like this. You may see their paper for, so better say clarification. And the next one is 15. We have given the name. It is proposed by 2010, and this is their formula. So we may read, whenever we read it, is looks like KD hat equal max, say it is what KHKB, and before I have explained KHB is what, may go back. KHB, we have the formula. He modified actually his formula. This is the one KHB. This is KHB. Okay, we may go there again. Okay, so you can see the formula, just the formula. So then I'm moving. Okay, by this we have other estimator. Let's skip. Say that means we count here. For example, when we studied this one, there are 28 rich regression estimators actually included in our this study. Okay, so this is actually methodology part for us. A lot of papers actually we studied, and after that we made a summary. Looks like that, and also uh, just listed the possible rich regression estimators. Okay, so our next plan actually, and I didn't write here. I'll go my our that paper. Our next plan was there. We have considered 28 estimators by a simulation study. It was a very, say, um, you know, um, many parameters, many distribution, many things that we studied, and I'm showing you our evidence from our paper. Have a look at that. Okay, you may see I didn't include my presentation because I thought I will not get time, but I'll tell the summary of our Monte Carlo simulation. Okay, so here if you see that we did the simulation and we generated the data from the regression model. There are different some types of regression model we have considered here. You can see this is actually p uh, explanatory variables we have included. Actually it was not possible. We studied up to 4 actually. We wrote a program by MATLAB. Then we have code by this code. Then we have various sample sizes we have considered. Then our application was 5,000. Then we calculated, we have considered, some correlation coefficient, which are all listed here. You may see, I think you can see or not, I'm just reading. So correlation coefficient among the explanatory variables we have considered high correlation. Actually we are doing 70%, 80%, 90%. Eigenvalue, eigenvectors also we calculated, and you can see the formula which one proposed by say Harold and Gerald. Okay, HK. It was K equals square root of lambda mx dividing by lambda mn. Okay, so skipping those, say here's our results. We have explained the results and a graphical approach, and also we have the table at the end of this paper, we have table. We try to explain our these 28 estimators by bar chart. Actually, bar chart should not say actually. We wanted to see actually which MSC, you know, is lower value. You understand that which one is lower value. Okay, so
Madam, if you can conclude in another 5 minutes, it will be good.
oh, I see. Okay, fine. Then skipping those. Okay, so skipping those. Now is come the application. All right. Say we try to say give say three examples in this real life data. So let us consider say here our observation. What we have done here, you can see that. So this is our model. Say yi equal beta 0 beta 1 xit looks like that. Say what is our y here, number of person say employed, and actually have taken data from here, Pasha and Shah, okay, 2024. And actually here has explanation, say here x1 x2 x3 x4 x5, these are explanatory variables. You understand that? Okay, let me see the results. Okay, so among the explanatory variable correlation we found like this, the high correlation exists, you can see that, so that means, what does it mean when we'll do the prediction? There is one of the assumption has say there should not be any correlation between explanatory variables. So we then what we have done, we calculated mean square error for our all estimated errors. So we can see that. Okay, let us see this. It's a very long table. Long table really is very hard to read. For this reason, we have done the graphical approach. Okay, let me read here. What actually our findings from see these are still performing well. Okay, because we just sort according to MSC. If you see 6 KB AM, AM equal to say we have seen that. And our second example, I didn't have excused in time. So you can see the second example, because we try to make it count from one data set. We try to use a different set data. You know, see here has this one and graphic. Okay, but this is now video. There are many estimates available right now. So let me ask you, is it
Your voice is breaking. Madam, you are not audible. Sadish sir, you are muted.
Sorry, Sir Shikra Bani?
I think she has some connectivity problem, looks like, right?
Yeah, some connectivity maybe, yeah. Yeah, we have time. Let us
Yes.
wait 1 or 2 minutes.
Sadiq sir, what do we do?
She has not
Yes,
joined it. So maybe
maybe
network
network
issues.
issue.
Yeah, we have the time up to
Yeah, another
11,
5 minutes.
and then next session 11,
Hello,
not 5,
hello,
no problem.
hello.
So
Can
5
you
minutes.
hear me? Hello.
Yes.
Yeah, yes, yes.
Yeah,
We
Yeah,
can hear
sorry,
you.
I told already, say we are having actually
Okay.
network issue. So I don't know.
Yeah, you can
Sorry,
continue.
I realized
You can continue.
I am not
yeah,
here.
we can conclude.
Hello.
Yeah.
Okay, I'm extremely sorry, that. I have done my presentation. I suddenly have seen nobody's talking with me.
Okay.
Thank you. Any question?
Yeah, is there any questions to the speaker? Yeah, if there are no questions, I think let us thank Dr. Shifra
Okay, thank
Banik.
you, sir.
Any
Actually,
there are
I'm really sorry. I
two
don't know when I
speakers
was
during the session,
disconnected.
Dr. Manish Kumar and Dr. Shifra Banik. Let us
Thank
thank
you.
both the speakers once more for the nice presentation today morning.
Thank you, sir.
Also, let me thank Professor Sadish Kumar sir for organizing such a wonderful event.
Yes, yes,
And since
obviously.
it's made online,
Thank you, sir.
yes,
Thank you. Thank you.
since
Thank
it's
you.
an online program, lot of people have opportunity for attending, and this is a great
Thank,
this is a
thank you.
this is a great effort to organize every
Thank
year,
you, sir. It was actually
June and December every year. Thank you
really
very much, sir, and
nice.
thank you for inviting me for chairing this session. Thank you very
Yeah,
much, sir.
Thank you. Thank you, professors. Professor, uh,
yeah. Actually, we are very grateful
thank
with
you, madam.
sir. Sir,
Thank you, madam.
yes,
Thank you, Professor Shipra Banik and Dr. Manoj Kumar.
yes, sir. Thank you very much, sir.
Thank you. Uh,
Yes, I always appreciate
for
your
your nice.
cooperation.
Thank you.
Yes,
Yeah, yeah. And
okay.
also, we wish to thank our Professor Dijo for chairing the session. And anyway, we have a good session that just concluded. And thank you all. Thank you, all the professors. Please.
Thank you, sir.
Yes,
Thank you.
yes, sir. Thank
Thank
you,
you.
sir. See you, sir.
Thank, thank
Thank
you.
you.
See you.
बहुत जरूरत है
We have 2 3 minutes. Uh, 5 minutes for the next session. Let us wait for 2 3 minutes and then start the session.
drawing the picture for the presentation. Okay, okay. Sorry, sir. It's 11:35. Yes, sir. Okay, okay, okay. And 35 അല്ലേ ജോയിൻ ചെയ്യുമോ? ഉത്തർപ്രദേശ് ജോയിൻ ചെയ്തത്. Sir, yeah, state president the conference. No, sir, it's 11:05. I'm sending the link, sir. Wait, in the mail. Yes, sir, I will mail you, sir. Just check.
Hello, Devika.
Yes, sir.
Hello. Just a minute. The speaker is trying to join. After that, we can initiate. I think Chair LMM Madam already joined. And hello, sir. And yeah, Madam. Speaker Rudra Pradhan is trying to join. He contacted me just before, and due to some network problems, he's get delayed. I have to check whether he joined or not.
ഹിന്ദി പഠിക്കുന്നു. Sir, have you joined? Join, sir. One second. So I have sent it to pradhan@gmail.com. Sir, I have sent it to pradhan@gmail.com. Shall I send it to rudrap@vgs? Okay, I send it in that. Another. Okay, sir.
Yeah, joined ചെയ്തു. Hi, Rudrapradan. Okay, Devika, please introduce the chair and do the needful for the further proceedings of the session.
Okay, sir. Good morning, everyone. A warm welcome to this invited section of the 10th International Webinar on Recent Trends in Statistical Theory and Applications. We are honored to have the section chaired by Dr. Eliama Matthew, Professor and Head, Division of Cancer Epidemiology and Biostatistics, RCC, Tirunelveli. Dr. Eliama Matthew is a leading expert in biostatistics and cancer epidemiology, and we are grateful for her presence today. We are also delighted to welcome our distinguished invited speakers, Dr. Rudra Pradhan, Associate Professor at the Vinod Gupta School of Management, IIT Kharagpur, whose research in econometrics and time series has wide applications in economic analysis. Dr. Masihuddin, Assistant Professor at the Department of Science and Mathematics, IIT Guwahati, who holds a PhD from IIT Kanpur and brings deep insights from both theoretical and applied statistics. We look forward to a stimulating section filled with valuable discussions. Now I invite Dr. Eliama Matthew to kindly take over and begin the proceedings. Over to you, ma'am.
Okay. Good morning, everybody. Thank you. At the outset, I thank organizers, especially Dr. Sadish Kumar, inviting me to chair this session, technical session. I'm very glad to chair this session. There are two speakers. Already we have 12 minutes are over. So we need to finish it by 12:05. There are two speakers. First speaker already mentioned, Rudra Pradhan. The topic is the dynamics of gender representations in Indian corporate reports, a textual analytics approach. We can have 20 minutes presentation and 5 minutes discussion. So kindly strict follow the time and start over to the presenter, Dr. Rudra Pradhan. Dr. Rudra P. Pradhan, Professor Pradhan, over to you. Please start. Professor Rudra Pradhan, please start.
You can see your slides. Pradhan, you can see slides. And now
Yeah,
slides are not
is it audible
visible.
now?
Yeah, audible. But you can
Okay.
move to the slide. Yeah.
Okay. Sorry. Is it okay now? Visible?
Yeah.
Okay. Very good morning to all of you, and I'm very sorry for this delay. There is some technical problems, and that's why it was delayed. So I'll be in time. So thank you, madam, for chairing the sessions and introduction about my presentation. So the topic is actually gender representations in Indian corporate reports, a textual analytics approach. Okay. So this is a part of corporate finance, and we applied a particular analytics tools just to know the corporate performance, and that too in the Indian context. And so far as a corporate finance and corporate performance is concerned, there are many factors which can be reflecting. And in fact, this particular topic is very interesting in the sense. So within many factors which can improve the corporate performance. So the issue is whether gender is a kind of factor, right? So normally gender means male impact or female impact. For examples, in a particular corporate, the particular performance, or either financial performance or any kind of performance, so absolutely depends upon the leadership, right? And if the leader is good, very efficient, and very systematic, dynamics, then there is a high probability that particular corporate will grow very well, and there is a high probability the corporate performance of that organization will be at the high stage, right? Now the question is, if the leader or CEO is very good, very efficient, very dynamic, then there is a positive impact, right? Now, this particular problem is that if the CEO is actually male type, how is the reactions, and if it is a female type, how is the reactions? Of course, when a leader is very good and very efficient, very dynamic, then these questions will not be there. But still, within that, this particular problem will be arise, because some of the instances male more efficient than female, and some of the instances female is more efficient than male. So that's how the hypothetical kind of situations. It's not that I am biased or very much kind of discrimination, something male female. It's not like that actually. It's very general kind of observation, general kind of feeling. That's why we try to understand. The understanding is that if the CEO or if a kind of leader, or BOG is having actually male kind of leadership, how is the reactions, and if it is a female, how is the reactions, whether is the performance is very high or very low, something like that. Okay, in that context, this is how the structure. So normally gender equality is a kind of one of the strongest or high class objective, and it is a part of sustainable development goals of United Nations, right? So in this context, this particular topic is well connected to in the kind of corporate environment, so that we respect gender in a kind of corporate environment. So I have already mentioned it is a very critical issue nowadays, and because the involvement of female in many corporate environment. Okay, some of the cases sometimes it's a kind of mandatory, some female should be there in the BOG or something like that. One time, I was in, University of Pretoria, and I saw that, the policy is that, every committee, etc. So one of the female member must be there. So the idea is that, to maintain the balance between the farm performance and, efficiency, etc., etc. Okay. So these are the problem area which I have already, highlighted, and the objective is, the three types actually. So analyze textual gender disclosure in Indian corporate reports. Second, identify governance and farm level factors driving disclosure. And third one is assess the impact of gender narratives on farm performance and valuations. Right? So, so there are lots of literatures, theoretical literature, methodological, different kind of methodology we normally apply to highlight these ones. Normally, in simple econometrics or analytics framework, so we use dummy modeling and to reflect this particular issue. But in this particular scenario, getting this data is slightly very problematic. So that's why sometimes wherever data is not there, so we use annual reports and through analytics and that the textual analytics, we get this particular information and convert into a kind of structure through which you can analyze these problems and like to see something which is actually very effective in this context, right? So it's a part of ESG and a part of also CSR, and that is how this particular work and the objectives which you are interested is very meaningful and very systematic to contribute towards ESG scheme and CSR schemes in the corporate environment. So it's a kind of win-win situations. And as I have already pointed out, there are. It's not something new actually. This particular gender equality, it's from very beginning actually. Last 100 years we are talking about this, and it was not so serious earlier days. But nowadays it's a very kind of serious, so that everybody should have equal rights, equal contribution, equal performance, and everybody should have the right to participate in this contest. So in this contest, with these objectives, with this kind of mindset, we have lots of theory, historically, and some of the theories I have already, mentioned here in this particular slides. You can find, there are, 5 different theories, starting from, stakeholder theory, and then signaling theory, legitimacy theory, agency theory, research dependence theory. So these are all actually a something kind of disclosures issue and in the context of gender diversity. But basically, actually, these are all theory connected to CSR activities. Okay. So what is the corporate involvement in the societal kind of issues, or bringing actually kind of gender kind of things in the corporate environment, so that it will have a better image, better branding, better kind of performance. So there are 3 aspects here from this literature. So gender-related disclosure in reports, then determinants of disclosures, and both diversity versus disclosures. So idea is that in any corporate, particularly BOG. So of course I have mentioned about the CA levels, but the thing is that at least one female member should be actually involved in the process. Of course, today's contest, so far as CSR is concerned, more or less it is a kind of mandatory. Okay, mandatory that somebody female member should be there in the process. And one way to investigate is that whether the involvement of female in the corporate performance is significant, or having some kind of high positives, or low positive or something like that. So that means technically what I mentioned earlier, that if there is a female involvement, then there is a positive reactions, or again, if the numbers are very high, then obviously the performance, or efficiency of the corporate sectors may be very high. This is again hypothetical scenario, and of course theoretically whatever theory is there, and we are trying to integrate, it's there is a fact actually, but still without data, without modeling, we cannot actually justify something. So this is mostly board compositions, and so these are all effect on farm performance, farm value, including branding. Okay, so so the mostly the gap is just to see the gender related disclosure issues. Okay, methodologically we use lots of annual reports to get this kind of data, and then our coverage is around 9,200 one farm observations, and that too time period from 2007 to 2022, and that to the total number of farms which we have considered is 1052, and the data is derived from Bloomberg, and basically farm size, age, birth trace, ESG scores, and then we proceed with analysis. Actually, we convert into kind of score, and then with that particular score, we there is a PDF documentation, some coding to address this particular issue. So we use basically Python script and then try to extract this information, gender related information, and try to connect with corporate performance. So these are the key variables, and for endogeneity point of view, so we consider also certain kind of additional variables and additional methodology, and mostly it is a kind of panel data study, and the typical technique which you have used in this particular scheme is two-step system generalized method of moments, right? And then the core idea is to just to know the determinants of disclosures, and then how the gender performance will be there. Okay, so I'm not going in details about this panel data modeling, and that to the method of system GMM. Of course, there are two types of generalized methods of moments. One is actually static GMM and dynamic GMM, and that to system GMM is a very dynamic in approach. And I'm directly coming to this particular analysis. So first of all, we try to check the trends. Actually, that's basically in a statistics. We like to observe that whether the trend is actually having something unique kind of things, or there is a kind of different flow altogether. So that itself will give you indication that the modeling is actually a high requirement. So of course, the trend is having kind of ranging from 0.14 to 0.24. That's female male ratios basically, and since actually the ratio is not too extreme like 0 or extreme like 1, so that itself gives the indication that it has something interesting in this particular study. So you can see here the trend is actually the ratio between male female in a particular corporate sector during these periods are actually in a kind of increasing trend. So that's the one of the beautiful inference, and that to what we expect and what we are guessing that that's how the sustainable development goals are reacting, and people are cooperating, all corporate sectors are cooperating all together. So this is another behavior. So again, it's falling, and then it has started increasing like anything, and against there is a ups and downs kind of male involvement, and this is something called as female involvement, and these are all trend analysis basically. And after that we are going for some kind of summary statistics, and so far as the average broad size is concerned, so we saw that limited progress in structural gender diversity, and may limited board independence and governance balance, and reflects typical profitability for emerging market firms, and against through ESG score and Tobin's Q, we suggest unwavering commitment to sustainability and social responsibility. Okay, so again, farm size, I'm just removing all these things since time is not there, and I'm just trying to trying to directly go to the discussion and implications. So there are two parts actually: farm level analysis and regulator point of view analysis. So in the farm level analysis, we have three different interesting observations, and again, on the regulatory point of view, we have three again important observations or important findings. So disclosures, and then develop internal policies for gender inclusive language in reporting, and promote women leadership via mentorships and succession planning, and some kind of reservations. And regulatory point of view, enforce mandatory textual disclosure standards on gender inclusivity, and promote gender diversity boards with particular incentives, right? So incentive based basically, and taxing, rating, something like that, and develop industry benchmarks for comparing disclosure performance, right? And civil society advocacy, then some of the theoretical contribution, like this particular analysis contributes to agency theory, which we have mentioned. So diverse board reduce oversight risks. Stakeholder theories, disclosures align with social expectations, and similarly research dependence theory, diversity improves access and legitimacy, and then signal hearing disclosures communicate governance quality to markets. Okay, so again, so key findings will be, so both diversity and disclosures have a high significant positive impact on farm value and farm performance. The second key finding is here gender inclusive language correlates with the Tobin skew and return on assets. That's the one of the corporate output which can give you a signal that gender has an impact. And disclosures operate as an independent market signals beyond a structural diversity. So it has both theoretical contributions and practical implications, like firms should embed with gender metrics into reporting and governance. Regulatory must ensure transparent and standardized disclosures, and civil society can drive accountability and awareness. And some of the limitations is there in the studies. Basically, this particular study is a India-based study, and Indian firms are specifically used. And in fact, the entire analysis is not so interesting, and R-square is relatively very low. Of course, some of the cases variables are interestingly significant, because compared to developed countries and European countries, our female involvement and the gender involvement, and against the kind of the particular formalities related to gender equality is not so well established in Indian context. So that may be the probably reasons why the R-square is relatively low in this kind of contest. With this, I am stopping here. Thank you very much. And I'm not. In fact, there are lots of econometrics results which I am not showing because of time constraints. And any questions, I am ready to answer.
Okay, thank you, Dr. Pradhan. So you finished that presentation, in fact, 2-3 minutes earlier. Anyway, thank you very much. It's a good topic that is nowadays, this is NLP is emerging area. In fact, particularly in medical field, this voice, their text can be converted into quantitatively. It's a very good topic.
Yes,
I have a few, one or two questions. Your sample size is more than 1,000, isn't it?
Yes, ma'am.
And your time period is from
2007 to 2022.
Till 2025. We have observed this time trend analysis. There are a lot of ups and downs, isn't it?
Yeah.
So what is the reason for that ups and downs? That is one thing. And then second thing is related to that, have you, this collection, data collection, have you used any random sampling technique, or how you collected the data? Is it, this ups and down, is it because of the data collection?
Okay.
That is.
Okay, madam. Okay, madam. So should I answer?
Yes, please.
Okay, very interesting, madam. The first part is, you mentioned that, in the flow train, there are lots of ups and downs. Am I right here? So basically, this is what exactly the reality. A particular farm performance cannot be steadily increasing, like, exponentially, or, steadily decreasing, like, in a linear framework. So there is always up and downs. It is a good signal, in fact, in a competitive environment. And if there is a competitive environment and competition, a particular firm cannot grow continuously in any aspects. Otherwise, the meaning of competition will get affected. So obviously, some company will give more effort and then they will grow. Then another year, some company will give more effort, they will go, something like that. So ups and downs will be there always, because it depends upon, it's not only competition. There are many factors, like, let's say COVID, right? Or like, global financial crisis, or like, Russia and, war, right? And recently this Israel and, war. So these are the, kind of, factors to which, a particular, activities cannot grow in a kind of, linear trend. There will be ups and downs. So far as a gender kind of, there's a male female ratio, which is actually one of the component in this particular, problem. So it depends actually, madam. Let's say in a kind of, board, and female involvement maybe one, maybe two, maybe three. Oh no, it depends actually. It depends upon, many factors. The, recruitment process and the retirement process. So that's why it is very difficult to maintain a kind of, flow. If it is a similar flow, of course the statistic will not work. So the ups and downs will be there, which will depends upon, many factors. The way I have already mentioned. Basically, there are two types: internal factor and external factors. Internal factor depends upon their, company policy or something compliance or something like that. And external factors, like, I have mentioned, environmental factors, or, like, COVID, GFC, etc., etc. That is the reasons actually the increasing in natures or decreasing in natures. It's sometimes ups and downs depending upon the situation. And statistically, that is actually good. Actually, we need that kind of, trend for, any kind of, modeling. If it is exception, linearly increasing or linearly decreasing or exponentially increasing or exponentially decreasing, then the model may not be actually very interesting. Particularly, the so far as the econometric modeling is concerned. Coming to your second questions, that, I think is related to time frame, right,
Yes, yes,
madam?
yes.
We covered according to the availability of data in the Bloomberg, because, some variables we have actually derived from Bloomberg, and some variables we have actually derived from the annual report. So we created a kind of, mapping, and then we have fixed that particular, time period. The way we